Hello, I'm Bill Fisher. I'm a professor and founder of the Digital Art and Design program at KCAD, that's Kendall College of Art and Design, and executive producer for the EPIC project, as well as author of the ICU Blueprint. I've designed toys, automotive interiors, animated and interactive media for over 30 years. Here's an illustration of me looking at you through my magnifying glass. On the left is a word balloon, and on the right is a thought bubble. So, what is the ICU Blueprint? Well, the name is an acronym for Inclusive, Socio-Emotional, Entertaining, and Universal Design. Unsatisfied with the separate and unequal aspects of accessible design, I started making blueprints for applying universal design to digital media. Prototypes are built and tested as part of the EPIC project. EPIC is an acronym for Engaging Production, Inspiring Classrooms. It's an ongoing project in collaboration with faculty, K-12 educators, and field experts. We've created 42 digital products, engaged 200,000 plus students, executed 20 field studies with 400 plus K-12 test subjects. Here are just a few of our collaborators: Grand Rapids Public Museum, Jim Crow Museum of Racist Memorabilia, Mental Health America, and Art Prize, the richest art competition in the world. I'll be addressing two approaches. First, accessible design. Multiple additional qualitatively unequal versions for every type of disability. And second, universal design. One qualitatively equal version for all abilities. Why universal design? Well, we can stop disenfranchisement. Unemployment rates are low for disabled persons, 14% for all disabilities, in fact, 45% for vision disabilities, and 53% for hearing disabilities. Bullying rates are high for disabled students, 5 times the rate for fully abled persons, which are at 10%. That's 50% of disabled persons being bullied. Disabled persons will tell you that social stigma is the main cause of these issues. Disabled persons are disenfranchised by unevenly instituted, separate, and qualitatively unequal accessible design solutions. Why universal design? One version for all. Universal design integrates accessibility features in a way that fully sensed persons can also benefit. Research has shown that video captions and audio descriptions improve learning and retention for all sensory abilities. Universal design provides an opportunity for the full participation of every person in the ongoing social fabric of our shared world, where people of all abilities can experience the media together at the same time, in the same place, on the same channel. Why universal design? We can reach the 47%. 47% of the U.S. population is living with a disability. 33% of the U.S. population is connecting to the internet, primarily with a cell phone. These persons will choose to engage more deeply with media that optimizes learning for them. Here's the breakdown. Hearing impairments, 15%. Blindness and low vision, 2.4%. Color blindness, 4.5%. Light sensitivity, 12%. Paralysis, 1.7%. Speech disability, 4%. And cognitive disability, 7.5%. You can see by this pie chart that that's nearly half of the entire population. Why universal design? We can lower production costs. Accessible design creates media for fully abled persons, then attempts to fix it by creating multiple versions and add-on features designed to provide minimal access for the disabled. Universal design builds accessibility into a single version from the start. Some accessible design fixes you may be familiar with include captioned versions for hearing impaired persons, audio-described versions, large text versions, high-contrast versions for sight-impaired persons, gameplay difficulty versions for cognitively impaired persons, With the Universal Design ICU blueprint, all of the above are integrated into a single version for everyone. The problem with games. Accessible games try to fix themselves. The cost to produce them is higher, the complexity is greater, and unsynced options mean all persons are unable to benefit from them. Stigmatization from an interface that calls out their challenges and delays their participation is also a problem. On the right are 13 individual control panels that a person with disabilities would need to adjust before they could start playing this popular educational game. Closed captions can be turned on and off. Well, captions should just be integrated organically. There's a toggle for background art, on and off. If the background art's distracting, it's going to be distracting for everyone. Audio descriptions, on and off. Well, audio description should also be integrated organically. We can choose text size. Text size should simply always be as large as space permits. We have a number of different ways to adjust difficulty levels, but we know that games can use simple AI to adjust the difficulty level of a game as the player plays it organically. I've developed a universal game blueprint for an educational game. I'll be demonstrating this blueprint for a game that responds organically to the needs of persons of all abilities without any add-ons. The aim is to enable persons of all abilities to play the game at the same time, in the same place, on the same type of digital device. Here's a snapshot of the game screen on the right, shown in a mobile phone. On the left is a color wheel in the shape of a pie. Each slice of the pie is a different color, and there are little icons that relate various fruits to each color, like a grape and an apple and a lemon. On the right is a diagram, part of one of the puzzles, and there's a next and previous button for navigation. This color wheel game is designed for everyone, including blind and sight impaired, colorblind, deaf and hard of hearing, cognitively challenged, and physically challenged. Let's play.
Color wheel pie. To play, navigate and answer questions by choosing next and previous, or yes and no, or use keyboard controls. Right and left arrows for next and previous, up and down arrows for yes and no. Revisit these instructions by choosing spacebar. This is Jordan's multi-flavored pie. It has 6 slices. Only 3 slices are visible right now. And those are red cherry, green mint, blue blueberry. Between them, 3 slices are missing. They are yellow lemon, cyan raspberry, magenta grape. You can mix the colors for the 3 missing slices by combining the colors of the 3 visible slices, red, green, and blue. Let's start by trying to make the yellow lemon slice. Can we make a yellow lemon slice by mixing a blue slice and a red slice? Choose yes or no. Sorry, that's incorrect. We'll try again later, but let's try making another color next. Let's try to make the cyan raspberry slice. Can we make a cyan raspberry slice by mixing a blue slice and a green slice? Choose yes or no. That's correct. Choose next to make another color. Repeat until all of the colors are made. Congratulations! You've baked a color wheel pie. Artists and designers use the color wheel to help them mix colors, the same way you mix slices for Jordan's pie.
Let's break it down. This universal design has built-in features for the blind and sight-impaired, colorblind, deaf and hard of hearing, cognitively challenged, and physically challenged. Features for the blind and colorblind include an organically integrated text screen reader, audio descriptions of the color wheel pie layout, also integrated organically. Some mental color models are created with pie flavors and keyboard controls where players can navigate with 4 common keys. Features for sight-impaired and colorblind include navigation color of blue and yellow, which optimizes quality for the colorblind. Minimum contrast of 4.5 to 1 for text and 3 to 1 for important graphics. A maximum contrast of 16 to 1 to avoid vibrations caused by photophobia. Large text, as large as screen size and margins allow. Features for deaf and hearing impaired. Reading speed. Pacing is controlled by the player with navigation. Captions are not needed because the text is organically integrated. And volume controls will respond to the native controls on any device. Features for cognitively disabled include simple writing using common language and minimalism, good visual hierarchy with consistent color used for each information type, controlling of signal and noise, important information punches off the screen, and simple navigation. Working memory requires only 4 actions. Some additional features for cognitively disabled include self-pacing, where the player controls the pace with previous and next navigation, dynamic difficulty adjustment, which can adapt with player success rate, memory associations that are created with smell, taste, and sound, and a simple voice, steady and neutral, with pauses and calm music. Features for physically disabled include large buttons, which are easier for persons with dexterity issues to navigate, and keyboard controls that are compatible with most assistive devices. Features for attainability are flat art, which are fast loading over slow internet connections, high contrast graphics that are readable in high glare environments, a responsive layout that adapts to any screen size, including a phone, and it is speech operable and can be voice activated. Some game types are more amenable to universal design than others. Some easier game types include simulations. These are simulations of real-world interactions that are often used for professional training, and VR technology is often utilized for these. Adventure games. These are story-based games where users make choices and complete puzzles to navigate the narrative and/or achieve a goal. Puzzle games include brain games that typically have simple graphics. They task players to solve progressively harder problems. Strategy games include players collecting items, making choices, then realizing the consequences. There is often an element of chance. Some of the harder games to make universal include action games. Quick physical and mental reflexes and the ability to rapidly task switch are required for these. Shooter games, these also require quick physical and mental reflexes and the ability to rapidly task switch. Combat games, one-on-one encounters requiring quick physical and mental reflexes. And sports games, quick physical and mental reflexes and rapid task switching is required to be competitive. Here I am again looking at you through my magnifying glass. Thanks for watching. I hope our relationship won't end here. Let's work on something together. Let's make something new, make something better, make something together. You can get ICU Blueprint updates via billfisher.substack.com. You can contact me, Bill Fisher, that's spelled BILLFISCHER, at bill_fisher@i-c-u.info. Check out the free ICU Blueprint for Inclusive, Socio-Emotional, Entertaining, and Universal Design at i-c-u.info.